Hello and welcome to our lesson on mixtures and alloys. A large part of this unit is dedicated to separating mixtures into a pure substance. However, sometimes a mixture is actually better than the pure substance. It has different properties that are valuable to us. So for example, cement is a mixture of sand, water and gravel. All three of those things have their own properties and they can be useful, but they're not going to be very useful for putting a house together. So sand on its own is not going to stick bricks together. But you mix these together and cement is a very valuable resource. Something a little bit simpler maybe, this salad dressing. I might not want just olive oil or just vinegar on a salad, but them together is delicious. Mayonnaise, for example, is another mixture. It's a mixture of vinegar, mustard, oil and egg. Again, we may not want to eat them separately. They might taste a bit revolting, but together they make something very nice. And finally, my favourite here, a cup of tea. I'm sorry, I just can't have it without milk. And it's a mixture, and that mixture is better than the pure tea or the pure milk, as far as I'm concerned. Okay, so if we go a bit biological, soil, without any of these key ingredients, it's not going to do the job it's designed to do. So plants are not going to grow, and that leaves us with huge problems. Blood is another good example. Red blood cells, white blood cells, plasma and platelets all have vital jobs to do, and that mixture is important, and the quantities in that mixture is important. If you don't have enough red blood cells, it's going to cause huge problems. So mixtures can be better than pure substances. This lesson is going to focus on a group of mixtures known as alloys, and you'll be very familiar with some of these names, even though you may not recognise that they're actually alloys. The definition of an alloy is a mixture of two or more elements where at least one element is a metal. So it's a mixture of metals. Here are some examples you might be familiar with. So brass is a mixture of copper and zinc. Both of those are metals. Bronze is a mixture of copper and tin. You might be familiar with that one. Both of those are metals. And steel, a very common alloy, is a mixture of iron, which is a metal, and carbon, which is a non-metal. But it's an alloy because it's a mixture and it contains at least one metal. So why is it then that the alloys, the mixture of metals, can be preferable and an advantage over a pure metal? Well, if you look at the diagram here, pure metals are made of only one type of atom or one type of molecule. So it has a regular lattice structure. And as you can see there in the picture, all those atoms are the same size, and so it forms this nice regular pattern, which is great, but it does mean that if you hammer it, if you put pressure on that metal, on those atoms, they're going to slide past each other with relative ease, and the metal is quite soft for a metal anyway. Again, that might be a useful thing. You might want a soft metal. It means it's quite malleable, but you don't want a metal that's too soft, and that's where the mixture comes in. By adding a relatively small percentage of another element, you disrupt that lovely regular pattern because the atoms are a slightly different size, and it's going to make it a little bit more distorted, and it stops the layers sliding over each other as easily, which means when you hammer it, when you strike it and put pressure on it, it's going to be a little bit harder. It's going to need a little bit more force, so it's less malleable. Now, why would you want anything to be less malleable? Well, it means it's going to be harder to shape. It's going to keep its shape a lot easier. So think about a bridge. You don't want that in the hot summer's day to start warping and changing shape. The other thing elements can do is they can change the properties slightly. So for example, if you add carbon to steel, it stops it corroding quite as quickly. So we don't want iron to rust, so we add carbon and it stops it rusting quite so quickly. So the sort of questions you're going to get on alloys is linking it to its use and why you would use that alloy maybe over a different alloy, or why you would use the alloy over the pure metal. So this question is saying, why would I use steel, which is iron and carbon, to make a bridge rather than pure iron? Well, it's not going to warp, it's going to be less malleable, it means it's going to be harder, and it's going to rust slower. So that's going to be much better long term, isn't it? Especially, you'll notice there's a lot of water there, which would speed up the rusting process. So this question's asking you to predict whether gold jewellery is pure or alloyed and justify your answer. Well, the answer is that it's alloyed. So 9 carat, 18 carat, 24 carat, it shows you, it's telling you the purity of the ring. And the higher the carat, the purer the gold is. And that tends to mean your 24 carat gold, even though it's got more gold in it, so that's why it's more expensive, it is softer, and therefore it's more likely to be misshapen. Pure gold is way too soft to use as jewellery, so they have to add a little bit of something in there to make it a little bit harder and a little bit less malleable, so it keeps its shape. Okay, so this is a pretty standard question comparing pure metals and alloys. Notice there's some data there. This was a 3-mark question. Pause the video and have a go, please. Okay, so let's have a look. Now, it's quite intimidating. There's a lot of information there. So if you are struggling, you would bug the question. I would always argue you should bug the question anyway, but it's particularly when you're not sure. So what does it say? It says this question about metals and alloys. So straight away I'm thinking, okay, what am I talking about? What am I thinking? Metals and alloys. It says look at the table, okay, which means use the table. If there is data in front of you, you need to use it. You will probably quote it, especially for a 6-marker. It says it shows some properties of metals and alloys. So we've got the list here of metals and alloys. Anything that is on the periodic table is a metal. Anything that doesn't appear, so just that one there, that there is the alloy. It has melting points, it has density. Now with density, you're talking about closely compacted particles, but reality is in a substance, it makes it heavier. So the denser something is, the heavier it will be. Relative electrical conductivity and cost per ton, okay, per ton. So there's lots of information. Now what they like to do is sometimes give you something that's not particularly relevant. So you have to think, okay, which of these bits of data is going to be useful or relevant for what we're actually using it for. So it says here, which metal or alloy will be best for making aeroplane bodies? Okay, so we need to look at this with aeroplane bodies in mind. So for example, density is going to be a huge issue here because we've got to get it off the ground. We're going to need a low density. It says choose from the table and it says explain your answer. Okay, so you're looking along and you're thinking, okay, aeroplane bodies, I want it to be light, so not dense, so that's not dense. That's not too bad. Maybe that one. Okay, that's the lowest 3 anyway, isn't it? Okay, relative electrical conductivity, I'm not entirely sure that's particularly relevant. Melting point, well, we don't want a really low melting point, do we? That's very low. So we'll get rid of tin. It's not tin. Bye bye tin. Hang on, let me cross out tin. Don't like tin. It's way too low melting point. It's not silver. It's not silver. Look how expensive silver is. Well, it's not silver. Way too expensive for making airplanes. Copper is far too dense. Lead is very dense. Okay, so can you see what I'm doing here? I'm narrowing down my options here. So I've got aluminium and I've got solder. Okay, so I'm looking along both of, oh no, hang on a second, look at that melting point there. I'm going to get rid of solder. Way too low melting point. Okay, so I'm left with aluminium. So I'm going to say aluminium, but what am I saying? Well, it's got a low density, it's got a relatively high melting point. Electrical conductivity, I'm not sure is particularly relevant for an aeroplane body. And the cost, it's a relatively low, in fact, actually it's the lowest cost of all of them, isn't it? So actually it's low cost. And when you're thinking about something like aeroplane bodies, that's actually going to be relevant, isn't it? Because, you know, as a company, you're not going to want to pay for a ton of money. So what was the answer the exam board was looking for? Oh, look, aluminium for 1 mark. Low density and lightweight. Now that word lightweight is important. You couldn't say light, because if it's a lot of aluminium, it will not be light, it will be heavy. But for its size, it's light. So you use this word lightweight, and that's what gets you the mark. and this idea of it being cheap or not as expensive as the others. So here's what it allowed. So ignore just light, there you go. Allow does not corrode. That wasn't mentioned, but they're allowing it anyway. Allow it's strong and malleable. Again, not mentioned on that table. Ignore other properties mentioned. So they don't want you to talk about relative electrical conductivity, and they're not talking about melting point either. Okay, guys, let's have another look. Okay, so last question of this lesson, guys. It says, which metal or alloy will be the best to join electrical wire? Choose from the table and explain your answer. So I've copy pasted that data again for you. Now we're going to join electrical wire. That means it has to melt in order to join them together. And obviously it needs to conduct electricity as well. So the answer they're looking for there is solder for 1 mark, and why it has a low melting point. And if you've got some general knowledge about soldering, that's exactly what they're doing there. So solder melts very, very quickly, very easily, and it's used for joining metal components because it conducts electricity. Second mark is dependent on the first mark. What does that mean? If you didn't say solder, if you'd said something else because it's got low melting point, you wouldn't have got the mark. Okay, that's the end of this lesson, guys. I'll see you later.